The density of bacteria in a circular petri dish. Blah, 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 blah. Okay, all this stuff. They give you a chart. What do you need to do for part A? Estimate f prime of 2.25. This should be very easy. All you have to do is find the average rate of change of f of r on the interval between 2 and 2.5. So 10 minus 6 over 2.5 minus 2. That's 4 over a half, which is 8. What were your units? Because it says using correct units. It should be milligrams per square centimeter per centimeter. So you could have said milligrams per centimeter cubed, but milligrams per square centimeter per centimeter, or milligrams per centimeter cubed. And 8 is the rate of increase of the density in square or milligrams per square centimeter per centimeter. Everybody good with part A? All right, part B. A lot of people had trouble with part B for some reason. I'm not totally sure why. It should just be 2 pi, and then times your right Riemann approximation of r times f of r. So make sure that when you plug in your y values, you are plugging in the value of r times f of r. So our first interval, I always start at the right here. Our first interval is from the 4 to the 2.5. That's 1.5 units. And then what is r times f of r for that? That should be 4 times 18, right? R times f of r is 72. That should have been your first value. Did you all get that? Plus the next one was 2.5 to 2, so that's a half. And then 2.5 times 10 is 25. And then the next one was 1 times 12. And then the next one was 1 times 1 times 2. And what did that come out to be? I don't have the scoring guidelines, so I have to trust your arithmetic. Oh. Why was r f of r confusing? Nope, it's the value. Remember, we're approximating. We're not actually taking this integral. We're approximating the integral by using the values of r f of r. What is it if you multiply it by pi? 845 or 269 pi. Great. Yeah, just multiply it out. You don't have to. They would give you the points if you didn't also, I think, but might as well. All right, for part C, is that approximation an underestimate or an overestimate? Well, what do we know about the function r times f of r? Yeah. F of r is increasing, and if r is getting bigger, and I multiply that by something getting bigger, that's also increasing. So we'll say that r f of r is increasing, and therefore a right rectangular approximation will be, for an increasing function, an overestimate. And that's the reasoning. That's all the reasoning you need. It's an overestimate because it's a right rectangular approximation on an increasing function. Everybody good there? Okay. Part D, the density is modeled by this function g of r here. We want to know for what value of k is g of k equal to the average value of g of r. So if we want to figure out when does this function equal the average value of this function, what's the first thing we need to find? The average value of that function, right? So how do we find the average value of that function? Use the mean value theorem for integrals. 1 over b minus a times the integral from a to b of g of r. And we want to set that equal to g of k. That's what we want to do. So what is this value over here? What is 1/3 of the integral from 1 to 4 of g of r? I remember from before earlier today, it was like 9 point something. 9.876. Set that equal to g of k. Graph both y equals 9.876 and y equals g of k. You know, you'll type it in as g of x or whatever, and then you'll just see where those two things intersect on the interval from 1 to 4. If it were me, I'd probably set the window on my graphing calculator to an x min of 1 and an x max of 4, just so that that's all I can see on my graph, so I don't actually accidentally pick something that's not on that interval. But that's up to you. What do you get for k? How does everybody feel about that? You guys feel okay about that at home? Zoom people?
Yeah.
Yeah? People here good? Nice, easy 9 points if you were taking that AP test. Yeah. Part C. That's because you took the derivative of a constant. I mean, you took the derivative of 2 pi times this. Yeah, I mean, that's just a constant. So the derivative of a constant is 0, but yeah, you can't, it would only work if you took the derivative of this from like 0 to x. And then you have x, f of x, but you don't need to use that to determine if f of r is increasing. Because it tells you up there that f of r is increasing and the r values are getting bigger also. So. But if you did do that, if you said, 2 pi times the integral from 0 to x of r f of r, that would be equal to x f of x. And so x f of x is increasing. Yep. All right. Anybody else? Any other questions on that first one? Okay. The particle one is a pretty good one, yeah? How do we do with this one? Pretty similar to all the other particle stuff we've done. The only one that was maybe a little different was part B, just a bit. Yeah, but hopefully you're able to figure it out. So part A, find the positions of P and Q at T equals 1. So to find the position of P and the position of Q at 1, we need to take the initial position. We'll say x sub P at 1 should be the initial position, which was 5, plus the integral from 0 to 1 of V sub P of T. Everybody agree with that? Initial position plus the displacement. What would that come out to be for X or for P? 3.7 what? 371. And then for the position of Q at 1, we had to do its initial position, which was 10. And then add the integral from 0 to 1 of V sub Q of T. And what did that come out to be? 5, 6 what? 4? Everybody good with that? And they haven't released the scoring guidelines or the answers, so I can't tell you how many points this is worth, but I don't know. My guess is that was probably worth 3 points if you were on the actual AP test. Probably 1 for each integral and 1 for final. I don't have any clue. I don't know. Probably 3 points. All right, part B. Are the particles moving toward each other or away from each other at T equals 1? Well, for part B, we know that particle P is over here and particle Q is over here at T equals 1. Right, particle P is to the left of particle Q. So we just need to figure out the velocity of particle P at 1 and the velocity of particle Q at 1. And then we should be able to determine if they're going towards each other or away from each other, right? So what's the velocity of P at 1? What? 0.841? That's positive, so P is going this direction. And Q at 1, if I plug in 1 to Q, what does that come out to be? -1 exactly? Oh, yeah. All right. So that one is moving to the left. And so therefore they must be moving toward each other. And your explanation would need to include, particle P is to the left of particle Q and moving right, and particle Q is to the right of particle P and moving left. So they're moving toward each other. Something like that. Good or no? All right. Zoom, you guys are good?
Yeah.
Oh, great. That's wonderful. Part C. Find the acceleration of Q at t equals 1. Now the acceleration of Q at 1 ought to be v prime of Q at 1. And you have a calculator, so your calculator told you what that value was. It was what, 0.027? 1.027? Wonderful. And we wanted to know, is the speed of Q increasing or decreasing at t equals 1? Well, the velocity of Q was negative, and the acceleration was positive. Therefore, the speed was decreasing because they had opposite signs. Everybody good with that? And we've talked about that a lot, right? Opposite signs of velocity and acceleration. Everyone good? Part D, find the total distance traveled by particle P from 0 to pi. So total distance traveled ought to be the integral from 0 to pi. It was pi, not 2 pi. Of the absolute value of, was it particle P? Yeah. Absolute value of velocity of speed, integrate speed to find total distance traveled. What would that come out to be? 931. Any questions or issues there with part D or any of the rest of that problem at all? You're all good? Zoom, are you all good?
All good.
Great. Wonderful. All right. How did you all feel about the problem with the spinning toys? Yes, I was informed, Tom, by Derek, that you really didn't like this problem, that you thought it was very difficult. That's what he told me. I don't know, but that's what he told me during last period. He said, Tom was complaining about this one. He said it was really difficult. And I said, that's weird. Number B.
Oh, yeah, I was getting on Discord about it. Yeah.
Does anybody know what he's talking about? What does that even mean? I mean, I know what the word Discord means, but Skype, but for, did you say it's Skype, but for people that are normal age? What is a normal age, Tom? Anything below my age is normal. I don't understand. Kylie hates the Discord app. Melanie also does not like it. And Nolan made a greater than colon parenthesis sign.
Samantha is only, Samantha only hates Discord because she's a boomer and doesn't know how to use technology.
Children are so strange. I don't understand children at all. All right. This company is designing spinning toys. And they use the family of functions cx root 4 minus x squared. So first thing we're going to do is find the area of the region in the first quadrant bounded by the x-axis and cx root 4 minus x squared for c equals 6. So that's the function 6x root 4 minus x squared. We just need to integrate that from 0 to, well, where does this intersect the x-axis? Into 6x root 4 minus x squared equals 0. X equals 0 and x equals 2, so we'll integrate from 0 to 2. Everybody good with that one? Okay. We're going to let u equal 4 minus x squared. So du will be negative 2x dx. We've got the 2, we've got the x, we've got an extra 3 in there. 2 times 3 gives us a 6, right? We don't have the negative there, so we'll put the negatives in. So we end up with negative integral of 3, we'll put the 3 outside, u to the 1/2 du. And then we got to change our limits of integration. Make sure you don't forget to do that. So if x is 0, u is 4. And if x is 2, u is 0. And then we'll probably want to flip those limits of integration to make this positive 3. And then when we integrate this, that'll become 2/3 u to the 3/2. And instead of being 4 to 0, we'll make it 0 to 4 since we got rid of the negative. Everybody good with that? Zoom, you good with that?
Yes.
Great. And that gives us what? 3 times the square root of 4 is 2, 2 cubed is 8, 16/3 minus 0. So we just end up with 16. It doesn't ask for units, they'd be inches squared, but doesn't ask. Everyone good there? All right. Question?
Why is it 0 to 4?
One second. I'm answering a question that was here. So it's 2 terms added together. You can't. No. You cannot multiply something that is not raised to the 1/2 power into something that is raised to the 1/2 power. If there's multiple terms here. If I had this 4 minus x squared times 6x to the 1/2, I can multiply this one into these. But I can't multiply this into these because this is not the square root of 4 minus the square root of x squared. Does that make sense? Okay. All right. Somebody in the Zoom was also trying to ask me something. So
I kind of figured it out. I didn't know you changed your limits of integration to u instead of substituting. Yeah.
Yeah. So as soon as you make that substitution, x equals 0 gives you u equals 4, and x equals 2 gives you u equals 0. Then we flip them to get rid of the negative.
Okay, thank you.
Yep. Everybody good now on part A? Yeah. All good. All right, part B. Tom's favorite part of this problem about the spinning toys that are not necessarily tops. So it says that the largest cross-sectional circular slice is 1.2 inches. So the largest cross-sectional circle should come when that function is at a maximum, right? That would make sense, right? The largest slice would come when the function is at a maximum, right? Somewhere up here. So we need to figure out where that maximum occurs. They give you the derivative very conveniently. So we will set the numerator of that derivative equal to 0 to figure out when we're at a max. So the c is insignificant, it's just a constant, right? So when does 4 minus 2x squared equal 0? X equals root 2. Yeah. And so that's the x value at which we're at a max. We want that radius, we want that height of that function to be 1.2 when x is root 2. So all we need to do is that Cx root, Cx, x being root 2, for minus x, again, root 2, squared, inside of the square root, equal to 1.2. And solve that for C. So we've got C times root 2 times another, well, this is root 2 squared is 2. 4 minus 2 is 2, so that's just another root 2. So we got 2C is 1.2, or C is 0.2. Easy enough? What? Yeah. It's as easy as like spinning some sort of spinning toy. It doesn't state that it's a top.
But it's not necessarily mean that it's like, okay, it seems like
Mhm.
it's not like,
Right, it's not necessarily a novel. It could be a children's book. A book is not a novel. A novel is a book, but a book is not a novel. It's like a square is a rectangle, but a rectangle is not a square necessarily. There are plenty of toys that spin that are not
but
tops.
it's just like a shape that's
What, okay, that what does a dreidel have to do with anything?
because the dreidel is just spinning down.
Okay, what does that have to do with anything?
That looks like a dreidel.
This looks like a dreidel. Doesn't look like one to me.
The x-axis.
It looks like the function y equals cx root 4 minus x squared placed on the xy plane.
It would be like
It doesn't look like a dreidel to me.
what
And even if you rotated that around the x-axis, this shape is not the shape of a dreidel.
I feel like if you really simplify it.
You know what it would look like?
I still stand by agreeing.
It's a spinning toy. You got one letter wrong, but yeah, it's a spinning toy. All right, everybody good with part B? And my argument with Tom? Everybody agree that this is not necessarily a top? Excellent. I'm glad you all agree. All right. Part D, for another spinning toy, notice the spelling there, T-O-Y, not T-O-P, T-O-Y. For another spinning toy, the volume is 2 pi cubic inches. We want to find the value of C for that spinning toy. Yes, okay. So we will just take a volume formula and set it equal to 2 pi. What's our volume formula for something that revolves around the x-axis? It's pi times the integral, ours is 0 to 2, of our radius, which is that function. Squared. Everybody good with that? So we just need to solve this thing for C, which means we'll cancel out the pi's first off, right? Because the pi's are going to go away. 2. And then I'm going to have equals, I'm going to have C squared in there. I'm going to put that outside my integral. I'm going to have x squared, and I'm going to have 4 minus x squared. Everybody good with that? Any questions or issues with that one? Okay. Then we'll have 2 over c squared equals, well, this is now an integral from 0 to 2 of 4x squared minus x to the 4th dx. 2 over c squared equals, what's the integral of 4x squared minus x to the 4th? That should be 4/3 x cubed minus x to the 5th, or 5, from 0 to 2. And if we plug all that in, we end up with 2 over c squared equals 32. I can multiply. 32/3 minus 32/5. 32/3 minus 32/5 ought to be 64/15, I believe. cross multiply, right? You get 30 equals 64c squared, divide by the 64, and then square root. C equals root 30 over 8. What a great C value for that spinning toy. Good one. Any questions on that? You looking at what other types of toys spin that are not tops? Yeah. You find lots of toys that spin.
Does that not look like it? Somewhat?
What is I can't.
Well, wait, look.
Yeah, that looks like it could be a top. It also looks like it could be like a Christmas ornament. I don't know. I can't really tell from here.
I'm looking at spinning top.
Yeah, you looked up spinning top. Great. You got a picture of a spinning top. Great.
That means
That's what that is. That right there that you showed me a picture of is a spinning top. This problem right here, you'll note, is about spinning toys. There's one. Spinning toy. Spinning toy. Spinning toy. I think I got them all circled. This is about spinning toys. Now, some spinning toys are tops, but not all spinning toys are tops. Great. No. The definition of a top is is a toy that spins. Yeah, sure. But not all toys that spin are tops. I mean, you could pretty much spin most toys. That is true. But I'm not getting into a discussion about Hello Kitty. Spinning jacks. There you go. Spinning jacks. What is jack? What are you talking about? All right, we need to do some rate FRQs. We're good on the graph ones. I think we've done a lot of the graph ones. We feel okay about the graph ones. Tomorrow we're going to do this one, which is one of the graph ones. No, it's not really one of the graph ones, is it? It's a little different. Oh well. Well, we'll do that in these ones tomorrow anyway. But we're going to do some rate FRQs today. If we want to do any more graph ones tomorrow, we can also. But we'll also do some graph ones tomorrow. Some rate ones. Oh, I don't need this. So let's move over. Which rate FRQs have we done together? We did the fish, we did the escalator, we did the bananas, right? Did we do this water being pumped into the tank one yet? Did I have you guys do this one or no? No, so you guys need some time to work through it? Okay. I know you can't see it in the Zoom, but now you can. All right, part A, estimate R prime of 2. Oh, that should be easy, right? 950 minus 1190 over 3 minus 1. What does that come out to be? Negative, what is that? What is it? Negative 120. Great. Indicate units of measure. So liters per hour, liters per hour squared, or liters per hour. Either one's good. Everybody good with part A? Pretty easy. Part B. What? Actually, I believe they gave, I had it up earlier. Let me see. I think it was 2 points. Yeah, 2 points, one for the estimate and one for the units. Lucky you. 2 easy points there. Part B, using a left Riemann sum, estimate the total amount of water removed from the tank during the 8 hours. So left Riemann sum will just be, first interval is 1 unit, so 1 times 1340. Next one is 2 times 1190. Next one is 3 times 950, and then 2 times 740. And what did that come out to be? 8,050. And is that an over or underestimate? Well, this function is decreasing. And it's a left rectangular approximation. So a decreasing function with a left approximation will be an overestimate. And your explanation would say the function is decreasing and a left rectangular approximation overestimates a decreasing function. Good? Or no? Good, good. Zoom, good. Zoom, good.
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 Good, Zoom. All right, part C. We want to find the total amount of water in the tank using our estimate from part B. So the total amount ought to be the initial amount plus the amount that flows into it, which is W of t. So plus the integral from 0 to 8 of W of t. And then minus the amount that we approximated that left, which was 8,050. What was the initial? 50,000. So what would that come out to be? $49,786 liters. And I did say to round to the nearest liter, right? Specified round to the nearest liter. So no 3 decimals on that. Everybody good there? Okay. All right, part D is the part people have struggled with. We want to know if there's a time between 0 and 8 where the rate of the water being pumped into the tank is the same as the rate of the water moving out of the tank. So that would mean we want the rate in, W of t, to equal the rate out, which was it R of t? Yeah, R of t. We want those to equal each other, right? Which would tell us that W of t minus R of t needed to equal 0. True? Do y'all agree with that? Or R minus W, either way. W minus R or R minus W would need to be 0. Right? Effectively, the rate of change would have to be 0. Yeah, that's what it's saying here, right? Is that the rate that it's pumped in is the same as the rate that's pumped out, right? That would mean that there is effectively no rate of change of the water in the tank. So we need this function, W minus R, to equal 0. Well, the only way we can make W minus R equal 0, be guaranteed that it does, is if W minus R changes signs on this interval. If it changes signs on the interval, it must have gone through 0, right? That's what the intermediate value theorem would say. So let's figure out what's W of 0 minus R of 0. Just based on the equations and the chart that they gave us. W of 0 minus R of 0 ought to be what? All right, W of 0 should be 2,000, right? 2,000 e to the 0 is 2,000. Minus R of 0 is 1340, so that should be positive. 2,000 minus 1340, what's that, 660? And then let's just try the value at 8. What's W of 8 minus R of 8? W of 8 is negative 64 over 20, e to that power, times 2,000, and then subtract 700. What do you get? Sixty-four 20ths is what? 16/5, so negative e to the negative 16/5 times 2,000. No. E to the negative 16/5 times 2,000. Negative what? That sounds good. Or whatever. That's less than 0. So it went from a positive value at 0 to a negative value at 8. And therefore, since we switched from positive to negative on the interval from 0 to 8, we must have hit 0 sometime on the interval 0. Does that make sense, everyone? You can't really round it, you get a different number. Everybody good with that? Zoom, are you good with that?
Yes.
All right.